Okay, we are in Advanced Math Trig, Mod 7. It is Wednesday, April 15th, 2020. So in our note-taking session, like we've been doing, top left corner, 4/15/20, April 15th. The title of today's notes is Parabolas. We've been dealing with conic sections, and we've already graphed circles. That was last Thursday. Monday we did ellipses. Tuesday we did hyperbolas. Now we're on parabolas. I've got a sticky note out here, or a sticky note pad. I do want to make an important point before I attack problem number one. Obviously, when you see the title parabolas, you're thinking, well, we've already graphed parabolas before. What we have done this year so far is a quadratic equation or a quadratic function. You don't have to write this down, guys. Do not write this down. This is me making an important note here. Remember back in, oh God, I'm not sure what month it was that Mr. DeMarco would have done this, but y equals x squared plus 3x minus 4. That was called a quadratic function, wasn't it? And because that was a positive x squared, and y equals this x squared plus 3x minus 4, we ended up graphing a quadratic function that was a smiley face. And it ended up being a smiley face, a parabola, and we found its vertex by using the formula, remember, negative b over 2a. We found out where it was going to cross the x-axis. We drew a smiley face, and we had a parabola that looked something like that. So we have graphed parabolas, but the ones you've graphed in your past have been in function notation. If you look at our problems today, like x squared equals 8y, and x minus y squared equals negative 4 times y plus 2, and y squared equals 12 times x minus 1, and finally y plus 1 squared equals negative 2 times x minus 3, the one thing you notice in all four of these in conic section form rather than function form, is that the squared value is isolated by itself. The squared value is isolated by itself. The squared value is by itself. And the squared value is by itself. Now, just like back in function form, remember when it said y equals x squared, when the x is the letter that's squared and the y is not squared, that was either a smiley or a frowny. It was opening either up or down. So my first teaching point, problem number one, guys, go ahead and write x squared equals 8y. The x is squared and the y is not squared. This is going to be a parabola opening either up or down, and because the 8, the number on that other side is a positive 8, right? Positive value is always up. If I would have said negative 8y, it would have been down. So everybody off to the side, next to this first problem, x squared equals 8y, write the word up. It's going to be a parabola facing up. Okay? Now, the vertex of this parabola, where would that be located, right? Because when you draw a parabola, you need to know where the vertex is located. Hey, guys, if you look at number 2 here that we're going to do in a minute, x minus 1 squared, and then there's a y plus 2. Because the x and the y have something attached to them, the vertex is going to be somewhere other than the origin. Well, on this problem here that we're about to do, since it's just good old x squared and good old y, doesn't say y minus 1 or y plus 2 or anything like that, the vertex is going to be at 0, 0. So I'm going to draw my xy coordinate system, and I'm going to put a dot right on the origin. And instead of CR for center, of course, I'm going to put V for the vertex of this parabola that's opening up. So think about it. I know it's opening up, so I wrote down the word up. I know where the vertex is located, and I plotted it. The one thing you've got to do now to draw this parabola accurately, think about it. If I told all of you to draw a parabola facing up right now, Most of them would look different because why? You don't know how wide to draw this yet. Is it a big, wide parabola? Is it a skinny, narrow parabola? How do you know how wide to make it? Okay, here's the new thing I'm going to teach you that in conic section form you need to do that you didn't have to do back when we were doing quadratic functions. You're going to take every single time the formula for p and set it equal to whatever the constant is that's in your problem. In this case, the constant is 8. And of course, if I divide both sides by 4, you end up with p equals 2. Oh, now the reason they use the letter p is because it's such an important point that we're finding. There is a point, actually it's called a focus or a focal point. There is a point that's 2 units up from the vertex. Oh, so basically the key step on these parabolas, once you know what direction it's pointing and where its vertex is located, is always use, again, always means every time you use the formula for p, set it equal to the constant, and when you get p by itself, that tells me there's a point, a really important point, 2 units up from the vertex. So I'm going to go up to, put a dot, I'll call that P for my important point. And there's an imaginary line, guys, running right through that focus point. That's how long. Oh, that's what the 8 is for. It's 8 units wide total. So that does not mean go 8 to the right and 8 to the left. It's a total of 8 units wide. So guys, running through that important focus point, you're going to draw a dot 4 units to the right and 4 units to the left, because I knew that the parabola that it was facing upward had a total value of 8 inches wide, meaning 4 to the right and 4 to the left of that important focus point. Okay? So let's give this a shot. Look at this thing here. Looks crazy. X minus 1 squared equals negative 4 times y plus 2. Well, first of all, guys, there's only one letter squared and one letter not squared. So it's not a circle, it's not an ellipse, it's not a hyperbola, is it? It's got to be a parabola. And yes, it's in standard form because the squared quantity is by itself. So I am about to come down here and draw a parabola. How am I going to do that? Okay, pay attention. Stay with me here. The first thing you've got to do is determine which direction it's pointing. Since the x is squared, just like the quadratic functions earlier this year, it's going to open either up or down. And because my 4 is negative, oh, it's a negative 4, it's going to open down. So write the word that describes the direction it's going to face. That's important. The vertex is always, just like on the other 3 conic sections, the opposite of the signs that you see in the parentheses. So if that says x minus 1, my x coordinate's 1. That says y plus 2. The opposite of that is minus 2. So guys, I am going to go right 1 and down 2. I'm going to put V for vertex, and I'm imagining this thing facing downward. So all I've got to do now is figure out how wide it is. So I take 4p every time you use the formula 4p, no matter what, and set it equal to whatever the number in your problem is. In this case, negative 4. Obviously, when I divide by 4, p would equal negative 1. Now freeze, what's that mean? Let's think. P stands for an important point, right? There's an important point located. Now it says equals negative 1 because it's 1 unit down from my vertex. Oh, so I go to my vertex and I put a dot 1 unit down. And there's an imaginary line going right through that real important P, that important point there, that's a total of 4 inches wide. Now, the negative is irrelevant when saying how wide. So you actually take the absolute value of that number to see how wide your parabola is. So if it's a total width of 4, that means we're going to go to that important point and go 2 to the right and 2 to the left. And now when I go back to my vertex, I know exactly how wide to make my parabola going through those 2 dots I just created. Okay? Let's give this next one a shot. It says y squared equals 12 times x minus 1. Okay, now what do you notice? I notice that the y is squared instead of the x squared. If the y is the letter that's squared, guys, it opens either right or left instead of up or down. And because 12 is a positive number, which direction would be positive? Well, that would be to the right. So this is a parabola opening to the right, whose vertex is at, okay, now careful, it says x minus 1. So my x coordinate is what? 1. And since it's just good old y squared and there's no number attached to that y, my y coordinate's 0. Agreed? So I'm about to draw a parabola whose vertex is at 1, 0. Put a V by it, not CR for center. Put a V by the vertex. I know that it's opening to the right. So I'm imagining a parabola opening to the right. Oh, but I've got to go 4P equals, you always take 4P no matter what, and set it equal to the number in your problem, in this case 12. So obviously when I divide by 4, P would equal 3. So guys, follow the bouncing pen here. Follow the pen as I talk. Look, there is a point that's 3 units to the right of the vertex. That's why you're writing all this down over here to stay organized. There's a focus, a point, 3 inches to the right of the vertex. So I'm going to go right 3 and put a really important point there. And that point, there's an imaginary line going through it telling me how wide this parabola is. Now this particular parabola, oh my gosh, is 12 units wide. So doesn't that tell me I've got to go up 6 and down 6 from that important point, because it's 12 inches wide total. And I would draw a parabola pointing to the right. Wow, that looks like that. Okay, a satellite dish facing east. And finally, y plus 1 squared equals -2 times x minus 3. Let's think. First of all, what kind of conic section is it? Because there's only one letter squared, it's got to be a parabola. Because the y is the letter that's squared, it opens either right or left. Because the number involved is negative, right? The constant is -2. That tells me it opens up to the left. And the vertex is going to be careful. Don't write -1, 3. Your x has a -3. Remember, it's always x, y as an ordered pair, isn't it? So since x has a -3 next to it, that means 3. Since the y has a +1 by it, that means -1. So I now know I am going to draw a parabola whose vertex is right 3 and down 1. It's facing to the left, so I'll put V beside it. There's my vertex right there. I always take 4p no matter what. That's my focus formula. And set it equal to the number involved in the problem. In this case, -2. Now careful, doesn't that mean now when I divide by 4 that my important point is going to be -1/2? Meaning it's 1/2 an inch or 1/2 of a unit to the left of the vertex. So I go back to my vertex, I go 1/2 a unit to the left, not very far away. There's the focus. And how wide is this parabola here? Oh my gosh, the number in front is a 2, isn't it? Again, you ignore the negative sign there. It's a total of 2 inches wide, so I only go up 1 inch and then down 1 inch. And start at your vertex and draw a parabola going through those 2 important points. It's a little baby parabola facing left. Okay? And just like we've ended the last 3 days of notes, I've got a problem here on the back. X squared plus 4x plus 6y minus 2 equals 0. That is not in standard form. When is a parabola in standard form? Remember, it's in standard form when the squared value is isolated by itself. So do you agree that the x squared plus the 4x, that family, is the only thing I want to isolate on the left? And I'm going to take the 6y and the minus 2 and shove them over to the other side. I'm going to subtract over the 6y, and I'm going to add over the 2. They get moved to the right because there's no squared values for either. Now, completing the square like we've been doing, what's the rule? Take your middle number, divide it by 2, and then square that answer, correct? So if I take positive 4 and I divide it by 2, I get 2. 2 squared is 4. Whatever I do to one side, some of you keep forgetting this, you got to go do to the other. So if I add 4 to the left, I got to add 4 to the right. This is now, remember, called a perfect square trinomial. It technically factors into 2 binomials that would both be the same. And what would they be? X, and then what do you get when you cut positive 4 in half? Plus 2 squared equals, now on that side, I've got negative 6y plus what? 6 when I combine like terms. I'm not quite in standard form yet, guys. Remember, my goal here is simply to get this parabola into standard form like we've been doing. If you look on the front, and you had to describe the standard equation of a parabola. Don't you want the squared quantity by itself? And what's on the right side of the equal sign? A constant and then a parentheses next to that. So do you agree that I've got x plus 2 squared here on the left, and on that side, I'm going to factor out a GCF of -6, leaving me with what inside here? Think with me. Think before I write it. What would you put in there? Wouldn't it be y minus 1? Because -6 times y is -6y, and -6 times -1 would be +6. So I did it. The squared value is by itself. I have a -6 in front of a y minus 1. And I successfully got my parabola into standard form. Okay? All right. Give this a shot. For homework. Today, again, is Wednesday, April 15th. So this homework or 4-problem assignment or 5-problem assignment is due Thursday, the 16th at noon. So by tomorrow at noon, you're going to graph the first 4 parabolas. They're all in standard form. Just graph them and show me what they look like. And then number 5, very similar to the one I just did. That one's just got to get manipulated algebraically and placed into standard form. So hit your pause button, copy down these 5 problems, graph the first 4, get the fifth one into standard form. So we've done circles, ellipses, hyperbolas, and now parabolas. Tomorrow on Thursday, we're going to end the chapter with a system of equations, a system of conics. We might have, like, let's say, a hyperbola and a circle and try to figure out where do they intersect. We'll sketch a picture and I'll show you a trick for doing things like that, which is an important topic for calculus for next year. Okay? All right, great job, guys. See you tomorrow.